These first two problems up here are a review from Friday. And so we need to remind ourselves how you find a root. In this case, it's a cube root. This little number in here, I didn't mention it on Friday, but it's called an index. And we'll come back to that. The number in the leg of the root symbol is called an index. And that index will be important. It's important in figuring these things out. If you recall, this can actually be broken down into 3 different parts. Because as long as the root appears like this, and you don't have any negatives underneath, actually a cube root you could have a negative, but we can break this down into 3 pieces if we want to. Now most of you will just do this in your head, but this is the cube root of 8 times the cube root of 6, 8 to the 6th, times the cube root of b. What, John? Why is it doing that?
Oh yeah. Is this still on 5-6?
It is. 5-6 is a very long chapter. I don't know why it's doing that.
Oh.
Okay, so if it doesn't, I may have to go back to. All right, here we go. It doesn't like. Girls, you may as well leave if you're going to do that. I'm not trying to be rude, but you're not going to learn anything and you'll keep other people from doing it. So stop giggling and let's move on. Cube root of 8. What number times itself gives you 8? 2. And your calculator can help you with that. Now, so far we've done nice ones that come out even. I'm going to fix that in a little while and tell you what to do with when they don't. The cube root of 6. Who remembers, what do you do with these exponents? Divide them. So 6 divided by 3. A to the 2nd. This one, once again, you divide,
B.
Gives you B. Okay, so this one is treated pretty much the same way. Now, you don't have to actually write out the breaking it down, but you're thinking of it in 3 different parts. So, cube root of 1,000. What times itself times itself?
10.
10. And do you know how to do that in your calculator?
Yes.
Okay, there's a cube root button under math. So we find out that's 10. Now, 7, when you divide it by 3, gives you 2, but there's a remainder. So what does that mean for the A's? I'm sorry? There's an A in front. How many of them? A to the 2nd. However many times it goes in is your exponent here. And what does this remainder tell you? There's 1 left underneath the radical. I'm going to leave a gap because we have a B to deal with. Okay, so that means we have 1A left underneath. There's 2 because we divided it out and we got a 2. The remainder tells you how many are left underneath for the variables. So, Sabrina, how about this B? We take what divided by what?
5 divided by 3.
5 divided by 3. That gives us 1 and a remainder of 2. So, what's on the outside?
B.
B. And what's on the inside?
B.
B. How many?
2.
2. B squared. Okay?
Oh, I get it.
Okay? The remainder is the exponent underneath the radical. And the whole number is how many came out. Yes?
Should that be AB squared?
This one here?
The second one. You have.
AB squared.
Oh, you put it together? You put it both under?
Yeah, both under the same radical. So, this is our simplified form of this. Now, some of your eyes may say, you might be thinking, wow, that doesn't really look any simpler to me, Sister Doughty, but there are ways that a math person needs to see it. And what you're doing is you're bringing as much out from under the radical as possible and leaving under what cannot be brought out without remainders. Okay? So that's a review from what we did on Friday. And we need to move on. Okay? Make sure you're right up with this. This is brand new. Okay? This is, before what we did was what you do when you have a product of two. And this is, what if I have a root? Okay? And it's a fraction. Now, it's an n, yep. Which means it's whatever number it is. If it's a square root, it's a 2. If it's a cube root, it's a 4. If it's a fifth root, it's a 5. So you'll have a number in this little leg, and then you'll have something in here and something in here. First of all, there are conditions. A and B are real. Okay, we haven't really dealt with anything that's not real, so we're pretty much, for this at this point, we're kind of assuming that. B is not 0. Why can't B be 0?
You can't divide by 0.
Good. You can't divide by 0. And n is an integer greater than 1. So we never have a number in this that's 1. Even when it's a square root, what is the implied number you don't see? 2. So if there's nothing in here, it's really talking about n being a 2. So you can have whatever number in here. You can have 2, 3, 4, 5, 25, 85, okay, whatever can be this number. N is what we call the index. I mentioned that before. So here we have an index of 3, a to the 27th, I'm sorry, not a to the 27th, a to the 6th, and a 27 in the numerator. So thinking about this is going to be true all the time, so I can break it down. Our direction here would be to simplify. I know I didn't write that down, but our direction is simplify. All these are simplify. But we need to know what it looks like when it's technically simplified or easier. So, based on this, how would I rewrite this? What do you think, Antonia?
The cubed root of 27 over the cubed root of a to the 6.
Absolutely. So it looks like this. Cube root of 27 over cube root of a to the 6th. You're breaking it down. Now sometimes you won't actually physically write that out, although for the fraction ones you really should. This is an easy one, so you might be able to get away with this one in your head, but honestly there are some tricky things that come out with these fraction ones that I need to show you shortly. Okay, so the cube root of 27. 3, okay, because 3 times 3 times 3 is 27. So if the top is 3, what do you do with these exponents again? Divide them so you get a to the 2nd. Okay, 3 over a to the 2nd. Okay, so far that's easy, right? Ish.
So far.
Okay, yes.
I'm still lost.
It's just
Sorry,
basic.
Sorry.
Is it, hold on, possible to do what? The number part can be, but the variable part won't simplify in a calculator. So you have to know the steps. Okay, the calculator can help you with the dividing, it can help you with the cube rooting of 27, but it can't help you with this variable. So there are things that you just need to be able to do that. Let's look at another one. The final answer cannot have a root in the denominator. So there's a little tricky something going on. This is, what is n in this case? 2. It's a square root, so it's an implied 2. It's square root. Good. Yep, that's it. Yay, light bulb moment. Okay. All right, so we have this. So we need to break it down, which means you put square root of 25. Ooh, Square root of 25, that was a lot of steps in one. Let me back that up a little bit. We need to go back to here. So it's the square root of 25 over the square root of a to the third, right? Okay. Most of you off the top of your head would know the square root of 25 is 5, because 5 times 5 is 25. Now we need to simplify this, right? So how do we do that? 3 divided by 2. So you get 1a on the outside and 1a on the inside. So you have a times the square root of a. However, we have this little annoying thing. All right, this might look perfectly fine to you, but my job is to make this not look fine to you. My job is to make you irritated because there's a square root in the denominator. So that should just kind of start to be like, well, that's just not right yet. So we need to find a way to get rid of this root in the denominator. Okay, and that's the steps that I'm going to show you. Okay, this is why it's so important to pay attention, because this answer would not be considered correct. We have to go further. Okay, so we need to fix this. Okay, we have a root in the denominator. Okay, all I did, Sabrina, I didn't change anything. It's just I gave more space. This is the same thing as what comes up in the next slide. Okay, so we just need to, and I just wrote a little note that we need to fix that. We cannot have this square root in our final answer. So we have to figure out a way to get rid of it. All right, now, John, what happens if I multiply this times 1?
It's the same thing.
Good. Beautiful. Keep that very firmly in your mind. Because what I'm going to show you is what 1 has to look like in order to get rid of this radical in the denominator, which is a huge math no-no for a final answer. Okay? So what we need to do, we're going to fix it by multiplying it by square root of a over square root of a. Okay, now, before we get too far ahead, because you got to wrap your mind around this. Alexis, why is this 1? How do... No? Philip, do you know why that's 1?
Because one variable is 1.
Okay, so that was a good attempt. Kyle, how about you? Why is this 1?
Anything over itself.
Good. Anything over itself, John, is 1. Okay? I'm coming back to you because you're the one that was very firm in that you can multiply something by 1 and it stays the same value, right? So here's 1. It's a funny looking 1. Stay with me. I chose it because if I take a square root of a and I multiply it times the square root of a, all of a sudden you'd have a square root of a squared, which brings it out of the radical, and we no longer have a square root in the denominator. You fix it by finding a way to get enough to make a perfect square. We need another a to get an a squared under that radical. Yes?
So it's okay to have them in the numerator but not the denominator?
Correct. Okay, so let's, now this is, like I said, this is not textbook wording, and as a matter of fact, they really don't explain what's going on at all. They just kind of show you the example, and they put these things in there, and there's for no reason. But I'm trying to make it clear as to why we do this. Okay? So, when we do this, multiply across the top. 5 times square root of a is 5 square root of a. Here's that thing we just did. Okay, we have the a, but this, when you put it together, is a times a, which is a squared. Okay? And sometimes it's not really clear to somebody why we did it until you see that it was done. Okay? Now, you said Alexis is probably thinking, because she looks very confused, but there's still a radical down there. Okay? Not really. How much is the square root of a squared? A. Okay, so the square root of a squared is actually a. Okay, all right, I'll put up the hide screen so it's not too much for you to see at once. Okay, here we go. All right, look. Here's where we were. Square root of a squared is a. Does everybody see that?
Yes.
The square root of a squared is a. So you always need, in math, need to clean things up at the end. Like you never want to leave a 1 times something. You never want to leave just an a times an a. You turn it into a squared. And finally we have our answer. Grace, we cannot have a radical in the denominator. So that's why we have to do something else to make it disappear.
Yes, ma'am. I got it.
Okay? So we have now 5 times the square root of a over a squared. And believe it or not, Grace Simmons, this is actually simpler than this. Even though it might not look like it to your eyes. This is what we call simplified, and this is not. Luke?
Couldn't the a squared in the square root of a, wouldn't that cancel out or no?
Oh, here? This and this?
No, underneath the answer. Couldn't
Here?
those two cancel out?
These? No, because a square is different than a square root. In order for... Now, we will be looking at the fractional exponent that is assigned to a square root. But even so, you're not allowed to have a radical in the denominator or a fraction exponent. So even though you might subtract the exponents, it still wouldn't be considered simplified. So even you can't cancel them because they don't have the same power. Square root is different than the squared. Okay, in order to cancel an a over an a, it has to be just a plain a over a, or maybe an a cubed over an a cubed. Or maybe you can subtract exponents if they're whole numbers and put it where the most of them are. But here like this is actually simplified, and you need to get used to looking at that and saying, yeah, okay, that one's done. Because you've got no radical in the denominator, and everything else is brought out that can possibly be brought out. Antonia?
Going back to that second part, the 5 over a.
Here?
Yeah, that part.
Mm-hmm.
To know how to, would it always be multiplying that square root of a over that over itself to even it out, like whatever?
Yeah. However much, like if there was an a and a b under here, you'd multiply it times the square root of an a and a b.
Oh.
Okay, square roots are a little bit easier because you're always going to just need one more. Because you need to make a complete set under there, so you're bringing out just one. Okay? You need to get a complete set. So since it's a square root, we're looking for a perfect square. I know that this is brand new. Once you get the hang of it, though, you're going to be okay. But you really, really have to work at it. Okay? At this point in your math career, it's work to make yourself understand. Okay? Now, we do need to do more on rationalizing a denominator, but before we do, I want to just backtrack a little bit, okay? Because we do need to cycle back to this. But what I need to do is show you a foolproof way to simplify a radical when you just have a number underneath. Because this, Jonathan and Grace, if this were put in your calculator and you put the square root button, it would give you a decimal. And we cannot, if you're simplifying a radical, you can't have a decimal in the answer. So we have to figure out a different way of doing it. When you are simplifying radicals in math, it's a math thing, okay? If you were doing a problem in like a physics class or something, you would need to get that decimal answer. Because a lot of the practical questions will need the decimal answer. But there are certain things that you need to be able to do that you're simplifying it and leaving it in what we call radical form. So this is an important skill that you guys need to learn. Those that have had geometry, you had a little glimpse into it. Those in my geometry class. Okay? But if you've heard it before, please don't get ahead of us. Okay? Yes?
I think I missed something because isn't it just the square root of 72?
This actually can be simplified, and I'm going to show you how.
Square root of 72 is 8. I mean, not 8, but
The square root of 64 would be 8.
I mean,
Square root of 72 doesn't come out even. Okay? That's okay. Alright. Look. Okay, you all really need to stay with me because this is important. It will go with you. You need to learn. Everybody needs to learn. Okay, look. It comes out as a decimal if you put it in the calculator, so you have to do something else. I'm going to show you a foolproof way to do it. So in other words, it's going to work every single time. It'll take you a little bit of effort. Excuse me. It will take you a little bit of effort, but you will always be sure that you are right. Okay? It's not presented this way in your book, so stay with me. The first step is to prime factor whatever number is underneath the radical. So prime factor, do you remember what prime factoring is?
Yes.
It's a factor tree. Okay? So in other words, you start with the number, you break it down into whatever times whatever. This is 8 times 9 is 72. Then you break that down until the ends of the factor tree all have prime numbers. Okay? You have a 2, a 2, a 2, a 3, and a 3. Okay? So prime factoring shouldn't be new to anybody. This is something that you were taught to do a long time ago, but it's coming back. Okay? It's coming back because I wanted to give you a foolproof way. So in other words, it will always come out right. Even if you decided to break it down in a different way, even if you didn't see 8 times 9, if you saw 2 times 36, it will still work. Okay? So, we have this, and what we want to do is we want to rewrite 72 as 2 times 2 times 2 times 3 times 3. We rewrite. So here's your step that you write down. Rewrite it as 2 times 2 times 2, the ends of the factor tree, times 3 times 3.
Why the other 2?
Why?
Why the 2 that's next to the 4?
1, 2, 2. Because this is a prime number. We came to the end of the branch. You break down until you can't break it down any further. And you can't have any 1s on the branches because they're not prime. Okay? If there is anything that can divide into any of the numbers, you have to keep going with the tree until it's done. Okay? All right. Stay with me. After you have broken it down like this, you begin to look, because it's a square root, you begin to look for pairs. Because remember, a square root is what number times itself. Right? So we have some pairs here. So you can write this down. Since it is a square root, you look for pairs to bring out. And if you don't know what that means yet, I want you to jot it down so you have a complete set of notes so that when you go back and you try to do something, you know what you're doing. So since we're going to look for pairs. We have a pair of 2s, we have a pair of 3s, and the next thing you're going to do is actually circle those so that you can see them. Okay? I said it's foolproof. In other words, if you constantly follow this process, you will always get it right. Okay? So, here we go. We have two pairs and we have a number that's all by itself. It's alone. Okay? Now, the ones that are in pairs get to come out because it's what number times itself. So for every pair, one comes out. And the one that's alone has to stay in. Okay? The one, bring out the pairs. So each time you have a pair, it comes out. Pair of 2s brings out 1, 2. A pair of 3s brings out 1, 3. And whatever is left alone and it doesn't have a partner has to stay under. So, we did, yes.
She said that.
Okay. All right, now, you never leave a 2 times 3. You clean it up just like in any other math. Right here. This is actually everything that we've had. This is all of it.
No, I wasn't finished writing the words.
From before where it says
Okay.
Square root, look for.
Okay, hold on. Shh. So, let's go back. This one. Look for pairs to bring out. Since it is a square root, look for pairs to bring out. Okay? Just to go back through. You got that part?
Yeah.
Okay? So here's our pairs that we brought out. The one that's alone stays under. Now there might be 3 or 4 alone. If you had a lone 2 and a lone 5 and a lone 7, they would all stay under alone together. Yep. All right. Shh. And then you clean it up a little bit. If you have that 2 times 3, you simplify so that it looks better. Okay? So for a square root, you factor and you bring out pairs. Okay? Let's look at 72 if it's not a square root though. Okay? Let's look at 72 if the index is changed. Let's look and see what happens if we have a 3. Okay? We're going to do the same exact process. 72 still factors the same way. Okay? Preston, you with us? I see all the stuff that you're doing there, but please make sure that you're writing important things too.
He's drawing me.
Okay. Shh. So, you should write down the cube root of 72. We're still doing that. You still keep the same direction that you prime factor. Okay? So, you rewrite it again. This is the same step. What's the only thing different in this step? The 3. So, let's see if someone can anticipate. When I had a square root, we looked for pairs. So we have a cube root, we're going to look for triplets, 3s.
Okay.
You're going to look for groups of 3. Look for groups of 3 because the index is 3. So there's just one group of 3. If it's not a group of 3s, it has to stay under. Okay? So we have these leftovers. 3, we have 2 of them, but we don't have 3 of them. So they have to stay under. So that means that a group of 2s comes out to be a 2. Okay, think about it. I mean, there's card games and stuff people play like this. You're finding groups of the same thing. 3 times 3 is 9. Because it's multiplied. Yep. Go ahead, Alexis. Yeah, it's going to be a regular plane 2. This, okay guys, listen up. Shh. Remember the definition of a cube root is what number times itself gives you what's inside. Since there's 3 of them, 2 times 2 times 2, that means that the 2 is the answer to that question. So this is really an 8. This is really the cube root of 8. So that gives you a 2 on the outside. 3 and 3, there's not enough 3's to bring them out. So they have to stay under. And I believe somebody asked a question, wait, why isn't it a 6? Because this is a times, it's not a plus. Okay? So you're looking for ways of making triplets if it's a cube root. Let's see. Okay, let's do another one. Okay, let's do the square root of 288. Okay? Square root of 288. What do you do first?
Whoa.
Factor it. Now, you can use your calculator to help you factor. What number do you know for sure is going to go into 288? 2.
Definitely.
So it's 140,000.
Oh, really?
Okay? All right. What number do we know for sure? Now, this one's done, right? Shh. What number do you know for sure is going to go into 144? I heard 12. How many times does it go in?
I want 12 of them.
Okay. This one is
2, 3,
6 and 2.
6 and 2. And 6 and 2. Okay, guys, stop talking. Stay with me. 6 breaks down into
3 and 2.
3 and 2. And 3 and 2. So everything we got at the end of the branches was 2's and 3's, right?
Right.
So let's count them so we can rewrite. We have 1, 2, 3, 4, 5. Double check for me. Is there 5 2's?
Yeah.
Hold on. Let's count together, Philip. 1, 2, 3, 4, 5. And how many 3's?
2.
2 3's. Okay? So now that we rewrote it, what do? We look for pairs. There's 1, 2, the lonely 2 by itself. So for each, okay, stay with me. Each one of these pairs, you bring out 1. So you bring out 1, 2 for this one. You bring out another 2 for this one.
Okay.
You bring out a 3 for that one. And we're left with the lonely 2 inside. So 2 times 2 is 4. Times 3 is 12. 12 square root of 2. Okay, now, just in case you think it won't follow you, you're going to need it in geometry. The geometry class is going to have this again, even though they already had a preview into it. In the next few days, you're going to have it again. It will follow you into your next math class, whatever that may be. It'll definitely go into calculus. It'll go into pre-calculus. It will go into everything. So just